So today we're going to continue on using properties of exponents. So I can use properties of exponents. So yesterday we talked about the product property, the power property, and the quotient property. Today we're going to talk about four. So the first one is called the power of a product property. So what this is saying is, take a look. Let's say I have 2 to the 5th, 2 times 5, all raised to the third. Well, as I said yesterday, this means groups of. So I have 3 groups of 2 times 5. So that's where I got that. Here's group 1, group 2, group 3. So from here, I would combine all my like terms. So I put not like terms, my same was 2, 2, 2, and then 5, 5, 5, 5, 5, 5. If I were to rewrite this could be 2 cubed times 5 cubed, right? Or to the third power. Third power and cubed are synonymous. Okay? So now, let's take a look at this next example. I have 3x to the 4th power, right? So if I have 3 and x next to each other, what operation is going on? Correct answer is multiplication, right? So I have 3 times x times 3 times x times 3 times x times 3 times x, right? So if I were to combine my quote-unquote like terms, I have how many 3's I have? 1, 2, 3, 4. And how many x's? 1, 2, 3, 4, x, 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 x. So if I were to write this in exponential form, I have 3 to the 4th power times x to the 4th power. So try to come up with the rule. This is a little harder to see, but try to figure out how did I get 3 to the 4th, x to the 4th. This is 2 cubed, 5 cubed. So let's see if you can come up with your rule of this, and then we'll see if we're right. Okay, so this next one, I have 7 squared y cubed z to the 4th, all of that squared. Okay, so let's rewrite this. So that means here's my first group, 7 times 7, right? Because I have 2 7s. How many y's? I have 1, 2, 3 y's, and I have 4 z's. Okay, so this is group 1. How many groups of this do I have? I have 2 groups. So I'm going to take this and cheat. Well, you guys have to write it. I'm going to just copy it. So here's what I have in expanded form. Okay, so now if I were to combine my like terms, I have 1, 2, 3, 4 7's. I have enough room. Well, I have 4 7's, so I could write that as 7 to the 4th. I'll just skip into exponential form. 1, 2, 3, 4, 5, 6 y's. I have 1, 2, 3, 4, 5, 6, 7, 8 z's. So z to the 8th. So this can be written as 7, 4 y to the 6th and z to the 8th. Right, so let's see your rule, 7, 4 y to the 6th, z to the 8th. So let's see if you were able to come up with your rule of this. It is the distribute property. Right, so I'm taking a look. If you don't see it still, I'm taking a look at my exponent, which is in this problem 2, and distributing it to all of my exponents. So I have 7 times 2 times 2, which is 4. Y times 3, y to the 3 times 2, which is 6. Z to the 4 times 2, which is 8. So I'm distributing it to all of my terms inside. So it is very similar to the distributive property. So if I were to have x, y, all of it to the b power, remember, I distribute. So I have x to the b, y to the b. Okay. So this is what we call a power of a product rule. So it's a little different than just a power rule. So it's like taking the power rule to the next step. Very similar to that as well. Okay, so why don't you guys try it on your own, and then we'll go on to the next rule. The next rule we're going to talk about is power of a quotient rule. So this is very similar. So if you to take a look, I have 3 to the 5th. This means I have 2 groups of it. So here's group number 1. Group number 2, I'm always going to be multiplying. So I have 3 times 3 over 5 times 5. This is going to be 3 squared over 5 squared. Okay, So this is equal to 3 squared over 5 squared. It's very similar to the one we just did, right? So this one is going to be m to the 8 times m to the 8 times m to the 8 times m to the 8th, right? Which is m to the 4th over 8 to the 4th. Hopefully you guys are able to see the pattern with this one as well. Yes, we are distributing for this one as well. The next one I have negative a over 9. This is 9 times negative a over 9. They all, man, I should have chosen different numbers. So if I were to simplify this, how many negative a's do I have? I have 2 negative a squared over 9 squared. Oh, but this one, be careful, right? Because you see how I have negative times a negative. Negative times a negative actually becomes a positive. So my negative sign actually goes away for this one. So I have a squared times 9 squared. So just be careful when you're dealing with negatives. If it's an even number, if my exponent is even, it'll always be positive. If my exponent is odd, it'll always be negative. So looking at my table, if I were to describe them using words, once again, it's a distributive property. Okay, so if I were to have this, it'd be x to the a over y to the a. All right, this is called the power of a quotient rule. So why don't you guys try it on your own, and then we'll go into the second to last rule. So this rule is called the negative power rule. So this is probably the hardest one or the newest one. It's different than all the other ones. It's hard to see. So basically, the only thing is you can't. There's a rule, unwritten math rule, where you can never have negative exponents ever. So you see in this one, I have 4 to the negative 2. You can't have a negative exponent, so you have to change it into a positive one. How? Well, 4 to the negative 2. All you have to do, this is the same thing as 1 over 4 times 1 over 4, which is 1 over 16, okay, which is 1 over 4 squared. So let's take a look. Okay, what did I do? Okay, all I did, I took this and brought it down to my denominator, and there my exponent became positive. So that's all you have to do for these negative exponents too. So in this one, you see I have k to the negative 3. How do I make it positive? Well, it's going to be 1 over k to the positive 3. So all you have to do is move it to my denominator, and then it becomes a positive integer, or positive exponents, excuse me. Okay, this one's a little tricky. I have 6x to the negative 5th, right? So this is why parentheses are so important. So my negative 5, is that to my x only, or is it to both the 6 and the x? It's only to my x. So the only negative exponent I have is x to the negative 5th. My 6 is actually positive. So I have 6 over x to the 5th. Why? Because my 6 is already positive, so I just want to leave that up on top. So how is this different than this example right here? Notice I have 7t to the negative 8. According to my power of a product rule, which we learned earlier, this negative 8 I distribute to both terms inside. So I have 7 to the negative 8 times t to the negative 8. Right, I have negative exponents, so those are red flags. How do I make them positive? You move them to the bottom. So I have 7 to the 8 times t to the 8. And now my expression is complete. Okay, so be careful where your parentheses are, because sometimes, like in the one we just did, the 6 isn't affected by the negative exponent, but then my 7 is for my other one, depending on the parentheses of that. So if I were to describe the rule, it's just going to be, it's pretty much the reciprocal, right? If I were to think about 1/2, if I were to think about 2 to the negative 1 power, right? This is the same thing as 1 over 2 to the first, which is 1/2. So you guys can figure all of this out. 2 to the negative 3, it's not negative 6, it's not negative 8. This is actually 1 over 2 cubed, which is 1 over 8. So that's the only thing. So if I were to write a rule If I have x to the negative a, this is the same thing as 1 over x to the positive a. So why don't you guys try these next 3 problems on your own, and then we're going to do the last rule. This last rule is a hard one. Okay, so 0 power rule. Anything raised to the power of 0 is always 1. As I said, it's the most difficult one. 5 to the 0, 1. This fraction to the 0, 1. Negative 3x to the 0, 1. That's it. So anything raised to the power of 0 is always going to be 1, no matter what. That's probably the easiest one. So as I said yesterday, on the next page there's the exponent rules organization chart. So I would put all 4 of these rules on that sheet so you can have one document to refer to when you're doing homework, when you're doing review exercises, because it will help you out. It can be very confusing, especially if there's a worksheet with all of these practice problems on the same one. They're all mixed together. That's why I put this organizational chart there for you to refer to, because it will be beneficial for you. Okay, so I'll see you guys the next day. If you have any questions, let me know then.